analysis is completed. We have got 0 errors, which is very rare when I'm using a package for finite element analysis. Now let's see the results. Click on results, and okay, so we'll go on this. This is called the plot contours. Basically, it shows you how the plot is, like how the object is being deformed under a pressure load or other things. So let's see. So this is just the abstraction of what the load is, and then we go to this selector, and I think something's wrong here. Okay, wait. Now you'll have to go to here. I think you have to go to. Okay, now you have to go to U. U is basically your deformation, and you have to go to deformed, right? Or maybe just primary, and you have to go to U2. Now for U2 basically signifies the downward deflection of your 3 axes, Y, X and Z. X is first, Y is second, so U basically shows you the deflection in the downward direction. That is when the load moves. So when I, wait, let me do the animation. So when I move the slider from here to here, you can see the load is moving, right? That's pretty cool, isn't it? Let me zoom it out for you. And these values depict the particular deflections at that particular point. So the blue one is the highest and the red one is the lowest deflection. So yeah, our analysis was good, but I just have to cross check these deflection values with the values that were given. So if I get it somewhat right, I think I'm on the right track. So we'll see about that, but I think my first model is pretty good, and I'll make a similar second model with some modifications, and I think I'll be done for it. So I have something to show to my professor. Okay, by the time my model finishes off, I have to finish 3 topics, right? First is advanced PS, second is my pointers, and I have to do practice problems too if I get some time, but for now I'll just start, and it'll probably take around 2-3 hours maybe. So let's finish this off, and then we'll head back to Abacus.
And raise your arms to the big black sky. Raise your arms the highest you can, so the whole universe will glow.
जाके खत्म हुआ मेरा. So I finished my DSA for the day, and also I'm getting good values for my model. Wait, let me show you. So the one that I left for processing, I'm getting good displacement values, so I can manipulate these values because these are the displacements that I wanted. So these are in meters, and it should be okay. It's 10 power minus 3. So if I multiply it by 10 power 3, then I'll get minus 0.28 mm. But I should be getting somewhere around 10 power minus 2. So I would be required to increase the force again, so I can get close to the displacement values, because this is still minus 0.28 mm, which is just not good enough. So I would be needing to increase the force again, and as iteratively as I increase the force, this will decrease. Eventually I'll get the requisite value. And for my DS part, I'm pretty much done, and I will take a break. I don't know how long, but I also have to clean my room. I have to also just watch this series, nothing else. Like, I'm gonna go for episode 1, season 1, and the portion खत्म करते हैं, आगे बढ़ते हैं फिर. उसके बाद I fixed the. So before I proceed with my analysis for another step, I want to show you the load that I applied. See, actually it was 1.18. Now I've made it 4, and then I'll have to again run it. So I'll go back to my packers. I'll go to the job. I'll create a new one, but before that I'll need to check if my load is different. This time I'll just make this 5. I don't know why. show you something. Now the graph that I was working on, the displacements, it's exactly the way I wanted, but I just needed to be somewhere around 3 to 5 or maybe 6 to 7 because I'm using a single track, so if you divide it, it would be around 3 to 5. And my load prediction of what it was, let me just show you the load here. Wait, this is the right file? Okay, sorry, wait. This is very scary because if I don't save my file, then I have to redo it again. I don't have the strength to redo all over again. It's so complicated, I swear to God. Okay, so this was the load. This is in pascals, by the way, and you can interpret it in megapascals, in 4.58 MPa or kilonewtons. Okay, so for this we had this displacement that I took a screenshot of, which is around 1 mm. So these are in mm. This 10 power minus 3 is, they are depicting the in meters because the whole units are standardized, so it's in meters and it's in SI units actually. So I will push this to maybe 9, I guess. I'll push it to 9. Okay, I'll go with 9 this time. Maybe I'll just go with I'll go with 9. That should do it. So I'm gonna go with 9 this time, and let's see what we'll have. I hope this time we'll get the exact displacements that I'm looking for. Even if not exact, somewhere around the region that I'm looking for. So I'll go to job, and again we'll do a data check. Before that, we have to create one, and I can just say just naming these files is another hurdle. So I'll say 1223. I'll just set up a name limit when I'm setting this. So 23. Oh, never mind. Okay. I didn't put it in that fashion. Okay. Jesus Christ. Okay, so final something. And then I just continue and I push it for data check. So it's a success. That means I can submit the job again. So let's submit it, and again I have to wait for 1 hour. So we'll finish it around 1 a.m. Let's submit. And let's wait. Okay, it's submitted. We'll pop out one another line, and that will confirm my submission. So it's done, the submission is done. Now again I just have to wait. Also, given the progress that I've made today, I think I've made a lot of progress, although I still have a lot to do. But I was working on some binary questions, basically working on the optimization techniques. That was just one part of it. Then for another, what am I left with? I have done a lot today, and I'm still left with a lot. Like, I still haven't done fluid mechanics as much as I want. Like, I have to practice the questions. I did the theory part. I have to practice the questions now. Also, I have to make another model for this. If I get the right displacements, then making another model is just cakewalk. It's cakewalk. Like, if I make the same model and I just infer with the load, I'll get the exact results. So I just have to make some modifications and redo and make the whole model. So I'll be done with the 2 models, and I think it will take around 2 to 3 hours to make another model because now I'm so used to it. So that's left. Yes, and I already have the results. And what else am I left? I don't think I'm left with anything else, but yeah, I have to do fluid mechanics. I have to practice the questions. So let's see if I can do it. Okay, I'll see you around. Here's some good news. Now for my previous displacement, what did we got? We change the orientation. So for my previous displacement, wait, where is it? Okay, this was the displacement that I got, right? It was close to 2.5, yeah, just around 2.5, nagging there. So this time around we have gone touching up to 3 mm. So there has been an increment about 0.5, with the force being incremented by just some margin. So if I double the force at this time, I think it would be easy for me to cross the 4 mm barrier. So the max that I want to touch is 5 mm somewhere. If I touch the barrier, then I am good to go and my model will be validated. So I'll now do my final load. Also, if you want to take out the nodes, if you want to plot this, it's very easy. Just go to job, you go to results, right, and you can go to this XY data, and then you go to the field output, you go to the spatial displacement, you pick up U2 is the downward displacement, right. Also the position is unique nodal, not integration point. Then you go to elements node and you get edit selection. Now since I'm picking up displacement under the rail, I can pick any of these points. So let's pick up this point here. To select that, and you can either save or just directly plot it. So I'll first save it. Okay, it's saved, and now I'll just plot it, and there we go. That's the displacement that we got, and it's pretty much the same displacement that we got from the previous node. So it's nagging around somewhere 3 mm, right? And I want to push it beyond. But before I do that, I take a screenshot for this one as well, because I don't want to lose the data. I've already done it for like 5 times. Now this time I'll make sure that I get a good perfect displacement that I'm looking for. So I'll go to load and go to edit. And I will not make it 8, it will be too much. I will just increase this 1 to 4. So 4 is going to be my final load. Okay, then I click OK, then it's done. And now I go to visualization. Before I do that as well, I need to delete this because it's already occupying a lot of data. So for those who are wondering why I'm not doing it in data, let's close this first. Before that, I need to save the model. Okay, it's saved. Then what do? We close it, right? We close it because, and now I'll go back to my application. I'll do a new job. To open your Abacus, you can type in Abacus CAE. That's the application name. Just have to wait for 5 seconds till it loads. Also, I did not purchase the license. The college provides me the license, so I can directly download it from their repository, which is available on their port, yeah, on their IP, through which I can just download it. So I don't need to buy any license. I think buying Abacus would cost me around $200. Of course, I'm not going to do it. It's available for free. Okay, now I'll open the recent folder here. And I'll go to job, click here, and complete this, right? When I show the result for this, it will show me that cannot be found because it's not there, so I'll delete it. And I'll delete these as well because I don't need them. Yes, and now we'll click on data check. For that, I need to create one, right? So name this one the ultimate final. This is something, I don't know. Something went wrong. Okay, wait. Just some random name. Continue. Okay. We can go to check. Okay. Check is completed. Right. Now I can submit it. And my model will be ready, up and working. So now what I'm going to do is I'll end my day here, And I also have to make another model, but that's going to be cakewalk as I mentioned before. And then I'll meet my professor tomorrow at 3:30. In between I might sleep. After 3:30 we also have a class at 6:30 I believe. And after that I might just sleep. So tomorrow is just showcasing my work. Like bulk of the work is already done today. So tomorrow is going to be a better day. Anyways, we'll see you guys. Also have to cross check. So 20 is done. 21 was my D-Day, but all the days corresponding to this day have been furnished. So now that I'm on 21, I just have to showcase my work that I've already done. Most of it, just one more model left that will be done within no time. Okay, so I'll see you tomorrow. Well, actually today, but it's already 21. It's 3 a.m. It's 4 a.m. Close to 4 a.m. It's 3:30 a.m. Sorry. So see you guys tomorrow. Bye.